My name's Alec Graham. I'm a geology consultant based out of Sudbury, Ontario. So I provide technical services and training and consulting for our various clients. And I've been working for Datamine for about a year or so. So today I'm going to talk to you about streamlining our modeling and our resource estimation workflows through Studio Geo. So in Studio Geo, we can create auditable, repeatable workflows that allow for easier collaboration. And ultimately, the goal here is just to keep the focus on geological interpretation and to reduce manual processing as well as minimize repeated work. And of course, we want to continue to generate high quality grade control and resource models. So first, what is Studio Geo? So Studio Geo is a newer offering from Datamine. And ultimately, it's designed to streamline the process of interpreting and updating geological models, and by extension, also the downstream products that rely on them. So this software supports geology professionals at every stage of the mining life cycle, from exploration all the way to resource estimation. And of course, it seamlessly integrates with other Datamine products as well as other industry standard databases. So one of the big differences with Studio Geo compared to some of the other Datamine offerings is that it is very much a workflow-oriented software. So the software is built around this kind of backbone, which is the dynamic modeling toolbar, which you can see here. And this allows for the creation of a customizable modular modeling workflow that you can continue rerunning every single time there's new data available, and it will already be set up for you. So this will generate a set of wireframes, and it will also create some other downstream products like fault block models, as well as categorical models. And this can all be done during the exact same operation. We can also insert macros at any point during the workflow, and this allows for a super flexible, highly customizable workflow, and it can produce a very wide variety of end products. For example, grade control or resource models, but the sky kind of is the limit when it comes to macro integration. So I would like to start just by showing a quick video of how the modeling workflow works. It's a little bit quick, but don't worry, we're going to go through it in a little bit more detail later. So when we first start our workflow, the most important thing is choosing our data set. So we're going to be importing our drill holes and then choosing the extents of our modeling. Next, we'll be choosing whatever domain and geological units we would like to model, followed by any other modules that you would like to add to your workflow. So in this case, we're setting up a fault block modeling workflow, as well as a block modeling task, which is going to fill all of our 3D models that we've created as part of the workflow with blocks. So after it's done loading, and it is making a dozen or so wireframes, so it takes a couple seconds, we end up with a handful of different products. The first one that we can see here, which is an integrated kind of watertight model that incorporates all of our geological modeling. And in this particular workflow, we have two different domain tasks. So we've also created a second domain, as well as these fault block models here. So by incorporating some 2D fault surfaces, we're able to split up our geology into fault blocks. And then finally, we've also filled all of our geological units with blocks. This is obviously a super coarse block model, but just to show how it works. So now that we've seen the workflow kind of in its entirety and what we can do with it, I'd like to start moving through each of the different modules and talking a little bit about them. So to start, we have our drill hole importer, which you may recognize from Studio RM. It's also present in RM. However, in this case, it's been integrated into this workflow quite seamlessly. So we can add our drill holes through the importer. We can also just select a pre-existing set of drill holes as well. So if you do use scripts or you bring your drill holes in a different way, that's okay as well. We can just select the pre-existing drill hole file. However, if you do decide to use the drill hole importer as part of the workflow, it allows for extremely easy updating of the drill holes. And you can do this either through a direct database link or through a table import. So one important option that we have when using the drill hole importer is we can either generate a brand new set of drill holes every single time, or we can just add new drill holes to an existing set. So being able to do that can be really useful because if we've made any changes or we've manipulated our pre-existing drill holes at all of those changes will be saved and we can just append any new drilling on top of those, which will make our 3D modeling a little bit easier going forward. And once this has all been set up, it's just a single click to run it again and import more drill holes going forward. So now into the meat and potatoes of the dynamic modeling workflow, we have our geological modeling, probably the most important part. So using the workflow, we can create quick, modular, and super replicable geological models. All of the settings that we use to generate all of these models will be saved for further iterations, so we can continue modeling them the exact same way every single time. It handles multiple domains, so we can have as many as we would like. And we also have the ability to incorporate static wireframes. So if we have a pre-existing explicit or implicit wireframe that we won't be making any changes to, we can still incorporate that into our watertight models, incorporate it into the workflow. It won't change, but it will still be considered in our model. We can use additional points from mapping or sampling to better constrain our implicit wireframes. So we do have some manual or explicit control over these wireframes. We have the ability to integrate fault structures. There's a picture here at the bottom right where we can see our blue model is being displaced by that fault structure. So we do have the ability to incorporate faults into our modeling as well. And although all of the wireframing that we've been talking about so far is existing within this dynamic modeling workflow toolbar, we also still have access to the full suite of explicit and implicit modeling tools, and we can all just use those as standalone tools as well. So we can also model outside of this workflow. We're not confined by it. And we can also automatically create block models as part of our process. So once we've generated all of our 3D solids, we can fill them all up with blocks. We have control over the parameters and criteria of our block model within the workflow. So for example, we can set our subcelling on a domain by domain basis. And any further modifications that we want to make to any of these block models, as well as grade estimations, those can all be done via macros, which can be incorporated into the workflow, or it can just be passed on to the resource geology team if we're done there. So to continue on a little bit with macro integration, they can be inserted at any point in the process, like I mentioned earlier. And macros can run all file-based processes that exist in Studio Geo. And that means that they can accomplish a really, really wide range of tasks. So these macros can be changed a little bit in our workflow. So we can turn on and off individual subroutines. And we also have the ability to change variable names or which variables are going to be used in our workflow. And before I head into the software, just a handful of other features that are present in Geo. We now have the ability to create bifurcating veins in the dynamic modeling workflow, as well, of course, with explicit tools like we would have in the past. And there's a photo of an implicitly modeled bifurcating system up at the top right. And we're also able to view the changing volumes of the model units for each model update. So we can create volume time graphs for every single iteration of our models that we create. So whenever we import some new drill data and we regenerate those models, we're able to see how that drilling impacted our models, taking a look at these volume time graphs. There's also a streamlined integration with a range of other Datamine products, of course, namely Studio RM, as well as some non-DM partner software providers. And it's going to be fully compatible with Mindtrust, which is an up-and-coming cloud-based data hosting service. So this will provide easier collaboration, better version control, and customized permission rights for individual users. So with that, I'll jump into the software and we can take a look at the dynamic modeling workflow live. So the first thing that I'll touch on is you might recognize the interface. This software is built on our Studio Core platform. So a lot of our other softwares will look similar in terms of user interface. We have the same 3D window that you may be used to. a lot of similar ribbons, with the exception of the estimation ribbon, which is missing. We can still access all of those estimation tools in Studio Geo. However, the user interface in the ribbon has been removed. So to use some of those tools, we'll have to use them through macros, as well as calling specific processes through the command bar at the bottom. One major change is the addition of the new dynamic modeling ribbon up here. So we have some tools that we can edit and manipulate our dynamic modeling toolbar down here, which of course is another new addition. So I'm going to move through all of these different modules, or as they're called in Geo, tasks, and we can take a look at what they do and how they work and how they all integrate together to create these downstream products. So I'll start by taking a look at the drill holes. So the drill hole and the extents tasks, these are mandatory. They just kind of come with this workflow, and we have to set these up if we want to do anything else. So first we need to import our drill holes. And like I mentioned, if we already have a pre-existing drill hole file, that's no problem. We're able to just grab that and bring it in here, and it's done. In my case, I'm bringing in these drill holes using some drill hole tables that I have on my machine. So I've already brought them in, but when you first do open up this drill hole importer, or this drill hole task, you'll be greeted with this dialog box here, which is the drill hole importer. You can also import your drill hole data by itself independently through the drill hole importer, and that's in the data ribbon. But this drill hole importer here, we're accessing right through the workflow, so it's going to be integrated with everything else. So I've already drag and dropped all of my drill hole tables into my drill hole importer, so you can just browse for them or you can drag and drop them. And I've made sure to map all of my column names to a correct output name. So I've chosen all of my mapping types, which we can do here as we flick through our different drill hole tables, just making sure that everything is mapped correctly. Generally speaking, the software does a pretty good job doing it automatically, but of course, good practice to go through and check. Then I can move on to my validate tab here. So the validate tab gives us an opportunity to take a look at any potential issues with our data. So the software will just flag them for you to start. So here I can see we're missing some caller records. And we do have the option to apply a quick fix in a lot of cases. So in this case, I cannot apply a quick fix. There's no way for me to fix this issue without me taking a look at the raw data or contacting our database administrator or whatever the solution may be. But for some other issues, for example, these here that have been flagged in my survey table, we're missing a survey at 0. So if I do want to make a quick fix here, quick fix will insert a new record at 0 with angles from the first valid survey record. So there is a way for us to really quickly just fix some of these simpler issues. And depending on what we want to do here, we can also export a summary of all of the validations in their current state. So whatever we have quick fixed to whatever we haven't quick fixed, we're able to export a report just so we have a record of what we've done. Also, when I'm importing my drill holes, just to mention, I did bring mine in as drill hole tables, but we have a button up at the top here, and this is where we can directly connect to one of our databases. So if you are doing a live database link, that's where you would do that there. So once I'm happy with my validations and everything is set up, I move on to my last tab where I can make a few last minute changes if I want, just choosing whether my positive dip is downwards or upwards, my desurvey method, etc. And one important option that we have here is the ability to retain existing drill holes. So I kind of touched on this earlier during my PowerPoint, but what this will do is instead of just overwriting my entire pre-existing drill hole file, it's just going to grab any drill holes that are new, that aren't in that pre-existing file, and it's just going to append them onto the file. So that's an option that we have. And once I'm happy, I'll choose generate drill holes. We'll be given a drill hole summary here, just with the amount of holes and some statistics like that. And then we would be good to go. Our drill holes will pop up in the 3D window. Mine have already been imported, of course, so they're already here. And now we're done bringing in our drill holes. So we can move on to our next task, which is our extents. So with our extents, we just need to determine how far we want our 3D models to extend out from our data. So there's a few different ways that we can go about this. In this case, I've opted to use a prototype model to confine my data. We can also use boundary strings, boundary volumes as well. So there's a few different options. And these prototype models, they can just be imported if you already have a pre-existing prototype model that you would like to use. But again, we can also generate it as part of the workflow. So it can also just be done right here. Mine's already been generated. And when I select it, I can take a look at my dynamic modeling properties over on the right here. And this is where I can change the parameters and the criteria for how this prototype model is going to be generated. So in this case, I've checked off automatic from drill holes, so it's going to fit it to my holes. And I've specified an extension distance from the most distal data points of 100 units, 100 meters. And I've selected these are just the default block sizes of 20 by 20 by 20. We can also specify a rotation angle for a prototype model as well if we would like. So the next component with our extents is setting up a topo. So this extents task does require a topo to work. In this case, I do have surface drilling, so I'm using a real topography here. However, if you're modeling something underground, you can just use a flat contact surface just to define the upper limit of your modeling as well. So it doesn't have to be a real topo per se. And once that's all set up, can move into the meat and potatoes, the domaining task. So our domaining task has created a suite of different wireframes here, as well as our combined solid wireframe, which we saw briefly in that PowerPoint. So the way that we set this up is we can set it up in our dynamic modeling ribbon. We just choose to add a new domain task. And I could go ahead and add another one right now if I want. We already have two, but you can have as many as you please. Choose my domain. So this is just the field that I'm going to be modeling. And then here you can see all of my different geological units, just like they are over here. So I have the ability to move them between these boxes, my stratigraphic box, my cross-cutting, and my ignore. So absent values will be ignored here. And then I'll just move the intrusion as well as these two shears to my cross-cutting area. So order does matter here. These are youngest to oldest, so that's how they'll be generated. And these two boxes are important as well because in our stratigraphic box, we're going to be generating two-dimensional contact surface wireframes. So in between our sandstone and our siltstone, we're going to create a 2D contact between the two of them. And then in our cross-cutting box over here, these will be generated as 3D closed volumes. So these will be solids. So if I click OK, it will populate my domain over here, my domain task. And one thing that has been added is this wireframe here. So this is an explicitly created wireframe. It wasn't generated as part of this process, but it was added using these dropdowns here. So we can add a 3D volume to be integrated with our modeling through here. So that can be just a pre-existing wireframe that you have. And we can also add a contact surface. So that would just be like a two-dimensional open wireframe. So when we are creating these 3D models, we're basically going to be creating 3D volumes that are either encompassing a particular unit or a model that's going to be drawn between the contacts of two units. If I would like to alter my data in any way, I do have the ability to code my data interactively in the 3D window. So for example, when I go to my implicit ribbon, two of the tools that I'm talking about that I'm kind of able to custom code my data for modeling purposes are my assign and my group tools. So I'll do a quick example with the assign tool. When I open up this tool and I've selected my drill holes and I've selected that lithology field, it's already auto-populated for me. If I'm looking at core photos, for example, I see here that this is a siltstone and then this orange is shear B. If I do decide I'd like to push that contact up a little bit, I'm able to select some of that interval. I can select siltstone, and I can choose a sign. So I'm basically just overwriting the coding that's already in the drill hole with my own coding here. And you can either overwrite your coding or you can create a whole new column and you can kind of code it fresh. So we have some tools at our disposal to prepare our data for a modeling and be able to make some changes interactively here in 3D. Another tool that's similar is the grouping tool. So I won't open that one up, but to explain how it works, I am able to choose multiple lithologies. For example, maybe in a sedimentary environment where I have a siltstone, a sandstone, and a mudstone. If I would like to model them all as a sedimentary package, I could just lump all of those different lithologies together, call them sedimentary rocks, and that would allow me to model them as a single unit. Since when we are doing our 3D modeling, we can only model a single categorical value at once. So that's another tool that we can use to help us with our modeling. So next, I'll take a look at some of the settings that are used to actually generate each of these individual wireframes. So each of these wireframes, we can edit the settings, its generation settings, independently of the other ones. So we can get each one to generate exactly how we would like it to. So for example, I'll start with this intrusion here. And when I choose my gearbox, that'll open up the vein surface tool. So the vein surface tool is also a standalone tool that you can find in the implicit ribbon. It's right here. It's called vein. You don't have to use it to model veins per se. It's just for modeling 3D volumes, basically. So we can also use this tool independently, but again, our settings won't be saved and it won't be incorporated in this larger workflow that way. So when I first open up the tool, immediately you can see some of these red dots and these blue dots here. So what these dots are is basically the first instance of the lithology that we're modeling in the drill hole and the last instance. And they're assigned hanging wall and footwall points is what they're called in the software. So some control that we have over these points is in our edit samples area, we can turn them off. So if we don't like one of these, we can just turn it off. Or we can swap them if the drill hole was drilled from a different angle. It's maybe the software has flipped them. So we can swap them back and forth as well if there's been any mistakes or any errors. Furthermore, we can also add some additional points. So this allows us to have some manual control over how our wireframe generates. And I can do a quick example with that so you can see how it affects our wireframe. So I'm just cutting a quick horizontal section through a wireframe. And I just need to make sure, okay, so our blue points are on this side. So if I create some new points over here, maybe I'm using some mapping, a georeferenced map, or I just want my wireframe to trend that way, I can place some of those points. So some hanging wall and footwall points. And if I choose to update my model, which I can do through here, or I would be able to update it through here, running everything, updating everything at once. I don't want to sit here for 10 minutes while everything generates, so I'll just do this single wireframe. Let it update. And it will respect your points and it will snap to them. So that's one way that we can control the generation of our wireframe. Something else we can do, and there is a whole bunch of different parameters we can set in here. I won't go through them all, but we have some control over boundary thickness, for example. So I can see that my intrusion is blowing out a little bit here. So I can try to cap that if I want. So maybe I can cap it at 25 meters width at the boundary. So that'll pinch it out a little bit. So we have a whole suite of tools that we can use in here to get that wireframe exactly how we like it. And once we're done, all of those settings will save, and every single time we run this whole workflow, they'll be generated as per the same parameters every single time. Okay, so we also have another domain here. We have just a couple of contact surfaces between zones. So this is a little bit simpler than the last one. And this also will spit out a combined solid using those contact surfaces. And just to show that we can have multiple domains being generated all at once, and we would be able to edit these wireframes the same way as we did in the previous task. So the next task that we have is a macro, and I'll just kind of skip that one for now and come back to it in a minute. And I would like to next go over the block modeling. So in our block modeling task, and I'll turn the block model on. It's currently just set to display as an intersection. So we're just seeing this 2D display. It will fill our 3D models with blocks as per our specifications. So when I select our domain geology in our block model, I can edit some of the properties of that block model over here. So this one in particular has been set up so that all of our mineralized domains, and the mineralized domains in this case are the intrusion, our shear A, and our shear B. They're being modeled just a little bit differently. We've applied subcelling of 2 in each direction, whereas our 2 waste domains, which is our sandstone and our siltstone, they're just being filled with these parent blocks. And just taking a bit of a closer look, you can see the subcelling applied to some of our units. Again, similar to the previous example, it's a super coarse block model, of course, but just for example's sake. Okay. And we can also color our block model based on our second domain, which is that regolith domain. And we can apply subcelling to the different domains here as well. Okay. So finally, just to quickly go over these 2 macros. So there's 2 here, the first of which, save interpretations.mac. So this is just a simple macro. Like I mentioned earlier, if we're going to be retaining our pre-existing drill holes, any of that coding that we've applied to our drill holes, maybe using the assign tool, like I showed earlier, or some of the settings that we choose when we're in that vein creation tool, some of that will save into our drill hole file in the form of metadata. And as long as that drill hole file has that metadata, then it will be generated, our 3D models will be generated the same way every single time. So it's important data that's saved within our drill holes. Whenever we're retaining those pre-existing drill holes, we're not going to be losing any of that data. However, if we are bringing our drill holes in a different way, like using a script or something else, we're going to be overwriting that pre-existing drill hole every time. So it's really important that we save that data. And this macro here is basically just extracting all of the important data from our drill holes and saving it as a separate file so that whenever we import new drill hole data, we can just append this back onto it. And that way our interpretations will just be saved every single time. And then we also have our grade estimation macro here. So we're running a simple grade estimation on, I believe, copper, arsenic, and silver for this data set. And that will create our grade model for us. So I just have it set from cold to hot colors for copper grade. And I'm only displaying our 3 mineralized domains right now, those 2 shears and the intrusion. Okay. So that brings me to the end of our dynamic modeling workflow, from start to finish. So we're beginning with our drill holes and we're basically ending with our grade model. And we can run that entire process once we get it set up for the first time, of course, just by clicking this single button here. And it will turn our drill holes into a grade estimation model, as well as all of the other products in between. So just to loop back around, Studio Geo workflows, they can encompass a ton of different possibilities. So I showed you one specific workflow on my end, but you can absolutely customize it a million different ways to make a whole whack of different products. So, I mean, a few examples here, grade control modeling that incorporates mapping done in the open pit or underground development. resource estimation workflows that can consider many mineralized domains as well as cross-cutting relationships. And of course, like I mentioned, automation through macros can include all sorts of different things like drill hole preparation steps, the generation of statistical analysis tables, grade estimation, report generation, etc., etc.